Welcome to Session 4 of GED Geometry Review. Today, we will find the area of triangles. Triangle area uses three ideas. Choose a base, identify the perpendicular height, and take 1/2 of their product. We will see why the 1/2 factor belongs in the formula, how to recognize height when a triangle is tilted, and what to do when the height lies outside an obtuse triangle. We will also solve missing dimension questions and practice avoiding the most common GED distractors. Why do we multiply by 1/2? Draw a diagonal across a rectangle. The diagonal divides the rectangle into two congruent triangles. Each triangle covers exactly half of the rectangle. If the rectangle has base 10 and height 6, its area is 60 square units. One triangle, therefore, has area 30 square units. The same idea works when two matching copies of a triangle are rearranged into a parallelogram. Triangle area is half of base times perpendicular height. The formula is area equals 1/2 times base times height. The base can be any side you choose. The height is the shortest perpendicular distance from that base to the opposite vertex. A small right-angle marker proves that base and height meet at 90 degrees. Compute base times height, divide by 2, and attach square units. You may divide first or multiply first, but keep the 1/2 factor visible so it is not forgotten. A triangle has three possible bases, but each base has its own matching height. Once you choose a base, look from the opposite vertex straight toward that base at a right angle. Do not automatically use the longest side, and do not assume a vertical-looking segment is the height. Perpendicular means the two directions form a 90-degree angle. Mark the right angle box before substituting. If you cannot place that box, reconsider the height you selected. Tilting a triangle does not change its area. First, look at the upright triangle. Mark the selected base and its perpendicular height. Now, rotate the entire drawing. The base, the height, and the right angle marker rotate together. The dashed height may no longer look vertical. That is completely acceptable. What matters is its 90-degree meeting with the chosen base. The base length and height length do not change during the rotation, so their product and the triangle's area stay the same. Trust the right angle marker rather than the way the diagram looks. For an obtuse triangle, the perpendicular height may land outside the triangle. Extend the chosen base with a dashed line. Then, drop a perpendicular from the opposite vertex to that extended line. The dashed segment is part of the measuring setup, not an extra side of the triangle. The height is still the shortest distance to the baseline. A slanted triangle side is not a replacement unless it actually forms a right angle with the base. Let us solve a basic example. A triangle has base 10 units and perpendicular height 6 units. Write the formula first. Area equals 1/2 base times height. Substitute 10 and 6. 10 times 6 is 60. 1/2 of 60 is 30. The final answer is 30 square units. If you answer 60, you found the area of the matching rectangle or parallelogram and forgot to take half. Use the units as a final check. A triangular banner has base 14 inches, perpendicular height 9 inches, and a slanted side marked 10 inches. The slanted side is extra information for this area question. Use the base and the perpendicular height. 1/2 times 14 times 9 equals 63 square inches. The right angle marker tells us that 9 is the height. The 10-inch side might matter for perimeter, but it does not enter the area formula here. Now work backward. A triangle has area 48 square meters and base 12 meters. Find its height. Start with area equals 1/2 base times height. Multiply both sides by 2, then divide by the base. Height equals 2 times area divided by base. 2 times 48 divided by 12 equals 8 meters. The answer is a length, so it uses plane meters. Check by calculating 1/2 times 12 times 8, which returns 48 square meters. Let us inspect 4 common triangle area errors. Error 1. Forgetting the 1/2. The repair is to divide the base height product by 2. Error 2. Using a slanted side as height. The repair is to find the perpendicular segment. Error 3. Using plane units for area. The repair is square units. Error 4. Using a height that belongs to a different base. The repair is to pair the chosen base with its own right angle height. Mark the base, height, and 90-degree box before calculating. Practice round 1. A triangle has base 12 units and perpendicular height 5 units. Pause and find its area. Use 1/2 times 12 times 5. 12 times 5 is 60, and half of 60 is 30. The answer is 30 square units. The distractor 60 forgets the half. The distractor 17 adds the measurements. Neither result represents half of a 12 by 5 rectangle. Visualize the matching rectangle to check your work. Final practice. First, a tilted triangle has base 18 centimeters and perpendicular height 7 centimeters. Its area is 1/2 times 18 times 7, or 63 square centimeters. Now a triangle has area 90 square feet and base 15 feet. Find the height. Use 2 times area divided by base. 2 times 90 divided by 15 equals 12 feet. Notice the unit change. An area answer uses square units, while a missing height uses plane units. Session 4 is complete. Triangle area is 1/2 base times perpendicular height. Choose a base, pair it with the height that meets it at 90 degrees. Divide the product by 2, and label area with square units. A tilted picture does not change the rule, and an obtuse triangle may need an extended base. If area is known, use height equals 2 times area divided by base. In Session 5, we will transfer perpendicular height reasoning to parallelograms and trapezoids. The narration in this video was generated with OpenAI text-to-speech using the Marin voice.